Running machine learning models is a parallel task that certain types of processors are really good at. CPUs are not great at running things in parallel, so running models on CPUs is very slow. But GPUs are great at parallel processing, so that's why they're commonly used for this. And dedicated GPUs like the RTX 4090 and its brothers and sisters are traditionally really fast, but they're also really expensive and use a lot of power. And that's why Apple Silicon architecture emerged as the next best thing for consumers to run at home that can be used to run local LLMs for a lot cheaper. Yeah, and I can't believe I'm saying this about Apple. It's actually a lot cheaper to run fully blown out MacBook Pro than a couple of RTX 4090s. That's the initial cost and the ongoing operating costs. I'm getting to the cluster, okay? Just give me a moment. I just want to mention that besides the GPU, if you want to run larger models, you're going to need more memory or RAM. In Apple Silicon terms, that's unified memory, which means that the CPU and GPU can use the same memory. You might already know this. So you can have a Mac Mini like this with 64 gigabytes of RAM, and even the most expensive consumer NVIDIA card only has 24, and that's $2,000 right there. Now, how do you use this stuff for machine learning? Well, to actually write machine learning code, you're gonna wanna use a framework or a library. For example, you might have heard of the old TensorFlow, then there's PyTorch, and those will run on Apple Silicon machines and NVIDIA and other hardware as well. But not too long ago, a new framework emerged that's optimized for Apple Silicon, and that's called MLX. It was released, I think, in 2023 by Apple's machine learning team, and it's supposed to squeeze more juice out of Apple Silicon chips for machine learning. And in benchmarks, is showing that it performs better than PyTorch. So essentially, it's Apple's answer to NVIDIA's CUDA. And this allows something like this tiny Mac Mini to run MLX and have pretty good performance.